A greatest common factor, which often is just referred to as GCF, an easy way to remember factors is factors fit. So if I have some cups, and let's say that one of my cups holds 12 of something. If I grab a cup that holds 6 and I fill it up to the top, and I dump it into the 12 cup, and then I fill it up to the top and I dump it into the 12 cup, nothing spills and it's completely full because 6 plus 6 is 12. But if I grab, say, a 5 cup, if I take the 5 and I fill it up to the top and I dump it into the 12, I'm up to 5. I fill it up to the top, I dump it in, I'm up to 10. I fill up the cup of 5 and dump it in, and it spills over. Because 5, 10, 15. So 5 doesn't fit. In other words, 5 is not a factor of 12. A number that is a factor of all other numbers is the number 1. Because if I fill up the cup that holds 1, dump it into the 2, fill it up again, dump it into the 2, it fills up the cup of 2 and doesn't spill over. Okay, so factors fits. And then if I want to find the greatest common factor, let me back up just one more time, is if you have a factor, if it fits, the biggest it could ever be is as big as the smallest number. Because if I have the number 6, I can't fit in 7, 8, 9, 10, 11, 12, and so on. So you already know that the greatest common factor could be is as big as the smallest one. All right, so a process to find that is you want to make a factor tree. You think of 2 numbers that multiply together to get 6, for example, and that would be 3 times 2. Then the number 3, thinking of 2 numbers that multiply together to get 3, we only have the option 1 times 3, and we're not going to use any 1s in our factor tree. And 2 is also prime, only 1 times 2 is 2. So then moving on to 12, thinking of 2 numbers that multiply together to get 12, I use 3 times 4. If you use 2 times 6, you're gonna eventually get to the same answer. 3 is prime, only 1 multiplied by 3 is 3, so that one is just gonna come down. The number 4 is 2 multiplied by 2, and so 3 times 2 times 2 is 12. Now, if we're looking for what's in common, we're only going to look at the bottom line. And looking for what's in common here, okay, I have a 3 and a 3 in common. And then I have a 2 and a 2 in common. So my greatest common factor, writing down the numbers that are the same in both, there's a 3 in both, and there's a 2 in both. There's nothing else in common to both of them, and 3 times 2 is 6. So my biggest number that fits into 6, no surprise, is 6. And one of the numbers that fits into 12 is 6, but this is the biggest number that fits into both. So there's a shortcut here that sometimes happens. The first thing I do is look to see, does the small number fit into the big number? 6 fits into 12. So I automatically know the answer is 6, because it could never be, your greatest common factor is the same size or smaller than your smallest number. So before I do all of this work, I say, oh, does the small one fit into the big one? And if it does, that's my answer. But otherwise, I've got to do my factor trees. Okay, so now This last example is the one that sometimes catches people off guard because they think there's nothing in common. If I break the number 10 down, I get 2 times 5. And thinking of what numbers fit into 10, 1 fits into 10, 2 fits into 10, 5 fits into 10, and 10 fits into 10. For 21, I break that down, and that's 3 times 7. So when I go looking for something in common, I don't see any numbers. But remember that when we're making a factor tree, we don't use the number 1, because I don't rewrite 2 as 1 times 2 or 5 as 1 times 5. The number that is the greatest common factor is 1, because there aren't any other numbers in common to write down here, and 1 fits into everything. So just a little warning is if you make your factor trees and you don't see anything in common to circle, then you know the greatest common factor is 1.